In this, we will begin thinking about the process called integration by parts, which is a method of integration, and we will do so by way of example. One thing that will be helpful is to make sure that you're reading your textbook, if you aren't regularly doing that, over the specific section, integration by parts. There's a way to describe the process, but the process isn't neat and clean. Always do this, then you can do that. So imagine we want to integrate x over the quantity square root of x plus 1 dx. And integration by parts needs to be understood in some way as this type of formula, I suppose. We've got something that we can't integrate directly, and we're going to use that, view it as two different things. One thing is a single function. The second thing is the derivative of some other function. Right? We're kind of viewing our given expression in those terms. And this always integrates into u times v minus v du. And your textbook has a proof of this as well. And so we're framing things in terms of u's and v's. And again, this will take a lot of practice. There's definitely no doubt about that. So in our first expression, we have lots of choices for what could be dv. So ultimately, we'll have u, the derivative of u, the derivative of v, and then whatever v happens to be. Typically, u is the thing that will be easiest to take the derivative of. There's a benefit of taking its derivative. In this case, x will be equal to u, and dv typically is the thing, the more complicated of the two expressions. So in this case, it will be x plus 1 to the negative 1/2 dx. And by naming our parts this way, we can take the derivative of u, which would be dx, and when you integrate dv to get v itself, that would have been 2 times x plus 1 to the 1/2, right, by the chain rule. So again, notice we started with defining dv and u, and then found the derivative of u and integrated to get v. This gives us all of our parts in the integration by parts process. So our original integral then, x over the square root of x plus 1 dx equals u times v. So u in this case is x, and v is 2 times x plus 1 to the 1/2. So I'll write it explicitly, x times 2 times x plus 1 to the 1/2. So this is u and v minus the integral of v du. So in this case, it is 2 times x plus 1 to the 1/2. This is v, and dx happens to be, or du, which is dx. So now I have a simpler integral with that in terms of x that I can integrate. So I'll do so here. I'm going to clean up u times v, so this is 2x times x plus 1 to the 1/2 minus the integral of 2 times x plus 1 to the 1/2. Well, this will be x plus 1 to the 3/2, and this will be minus 4/3. And since this is an indefinite integral, I have to remember plus c. Now, some things that you do need to be aware of before we end this particular segment is that you can make different choices, right, as far as integrating and come up with an equivalent but different answer. And so it may be the case that you've done things correctly and still have something different from the answer in, say, the back of the book or a given answer. And that doesn't mean you've done anything wrong, you've just done some things different. Right? And this constant affects everything. Right? Because your constant and my constant will be different, but we could have equivalent expressions depending on how things simplify. Right? So the only way to test this is to actually take the derivative of your given function, if you weren't sure.